Welcome back to the Trading Cryptocurrency with Python series. In this video, we are going to implement one of the trading strategies we previously backtested live on Binance API. In this video, we're going to kind of lay the groundwork, gather all the data we need live from the API in order to actually execute our buys and sells. So in this video, we're going to do just the simplest strategy we've backtested so far, that first Bollinger Bands strategy. We're going to buy when it crosses the lower band and sell when it crosses the upper band. The reason for this is we want to just start with the simplest implementation possible so we can really understand how the API works, and then kind of give the tools necessary to implement more complex strategies on the API in the future. So I've started here with that gathering data chunk of code that we've been using in all the previous videos. If you haven't seen this yet, this code is all explained in part 1 of the series. So just to start, I've pulled in also these two functions from part 2 of the video that compute both the simple moving average as well as the Bollinger Bands. So I'll start here. The result of this code, as we've seen in the past, is a data frame of all of the cryptocurrencies we're interested in. In this video, we're going to use Bitcoin, Ethereum, and Litecoin. And you can see we have the prices for both, as well as some other information here, all in one data frame. So from this data frame here, we still need to add on the simple moving average and Bollinger Bands features so that we can use those for trading later. So to do that, we're going to start by iterating through that list of symbols we have. So for symbol in symbols, we are going to want, remember this function takes in, the simple moving average function takes in a series from that data frame. This is the prices, and then the window that we want to calculate. We're going to use a 20 period simple moving average. So this is going to be our data frame. We're going to pass that symbol. And we want the close price, as that will be the most recent price change that we have in this data frame. So we're going to pass the whole series into SMA, and this also takes a window. I'm going to say window is 20. And we are going to call this a new column here. We're going to call it symbol SMA. So I'll run this outside of this chunk here, so we can get a look at that. This is USD underscore close. And you can see we have now added on our 3 simple moving average columns. And again, these first 20 instances of or first 20 indices of this data frame will be null, just because it needs 20 previous values to compute. So at the 20th index, we're starting to compute our simple moving averages. And then from that, we also want to compute our Bollinger Bands. So we'll do that. This takes in our data column, our simple moving average column, our price column, simple moving average column, our window, which is 20 again, and then the number of standard deviations we want to use for those Bollinger Bands. We're going to use 3, but that can kind of be tuned to your liking. So we'll call this lower band, I'm going to compute the lower band and the upper band, and I'm doing it in one line here because remember, this Bollinger Band function returns both the upper band and the lower band. It looks like I actually switched those. It should be upper and lower. So then we'll call that Bollinger Bands function, and the inputs to that again are our close price column, so this is our data parameter. Then we have a simple moving average parameter, which is the column that we just computed, this one here. we have our window is 20. So this is going to use the previous 20 indices worth of data, and this is 1 hour interval. So the past 20 hours it's going to use to compute each moving average. And then our n standard deviations is going to be 3. And again, this parameter can be tuned. A larger number here will give you a wider band, and therefore a more conservative strategy. A lower number there will be a tighter band and a more aggressive strategy. It'll trade more often if that number is lower. So we'll run this here. Where did we go wrong? Oh. So now we can take a look at our data frame, and we can see we've also added those upper band and lower band columns. And again, these nulls in the first 20 indices. So let's move that into our main function there. And we will also want to remove those NAs. So we can do that with dfs.drop NA, and we'll do this in place. So now you can see if we run this whole chunk of code, we are going to grab the previous 48 hours, merge those all together, and then we're going to compute both the simple moving average and the upper and lower band, and then drop the null values. So what we're left with here is our clean data frame. It should be 28 rows in this case. So we grabbed 48 to start and then dropped the 20 nulls. And they're all filled in here with the data we want. So next what we're going to do is we're going to make this into a function, actually, because we're going to want to call this chunk of code many times as we're implementing this live trading script. So we're just going to call this whole chunk gather data. And this is going to take in, so to define that, this is going to take in our symbols and our start n hours ago. So this, if you want to grab more data, you can up this number. We're just grabbing 2 days worth in this case, 48 hours. And then when we define this function, everything below needs to be indented one line, and we can return the data frame of interest, which is dfs. So now you can see we can very simply just call gather data. We can pass our symbols and the second parameter here, start n hours ago. We want to do 48. And we can see we've gathered 48 hours worth of data, and we have all of the features we need. So the goal of this strategy, again, to sell when we cross the lower band, or to buy when we cross the lower band and sell when we cross the upper band. We're going to need to compute this, since we're grabbing 1 hour intervals. We're going to need to refresh our data set at the top of every hour to compute those Bollinger Bands, and then we'll know what those thresholds are that we're going to buy and sell at. So to do that, we're going to use, we need Python to run continuously and check, is it the top of the hour? If so, we want to grab that data. And this, there are definitely better ways to do this, but we're going to go through just kind of the most simple use case that we can do this all within this script. You might find elsewhere online there's very complex tutorials on how to build these trading algorithms using cloud services to host them and kickoff scripts at certain times, and you can really connect it all together kind of in a better way than we're going to do here. But again, the goal of this series is really to make this accessible for the person that has never used Python before, is not too familiar with cloud services, Binance API. So this is really the simplest way to do this, and it does work well. It's just there might just be kind of better, more complex ways to do this, I'd say. But we're going to use a while loop here to get first to run continuously, and we're going to say while true. So what a while loop does, it will run until this condition is false or is not true, basically. So while this is true, this loop will continue running. We're passing true there means it will just run forever, which is what we want in a trading bot, right? We don't want it to stop trading at any point, unless you can turn it off whenever you'd like. But so we are going to say while true, and we've also imported this date time module here, and this is what we'll use to check if it is currently the top of the hour, and if so, we want to refresh our data. So as I mentioned, the next thing we're going to want to do is use that date time module to determine whether or not it is currently the top of the hour, and if so, we're going to want to pull or refresh our data from the Binance API. So the way we're going to do that is using the datetime.now function. So this returns the current date time. Current date time with year, month, day, hour, minute, second, millisecond. Specifically, we're going to be interested in the minute and the second attribute of this. So you can see it's currently the 45th minute of the hour. And basically what we're going to want to do is, first we want to come into this process every time, or every 10 seconds basically. So the way we're going to do that is if datetime.now.second mod 10 equals 0. So to explain this mod here, this is basically asking if you divide the second, the number of seconds, by 10, if the remainder is 0, or in other words, if it's the current multiple of 10, then this will be true. Otherwise, we're going to wait until that becomes true. So it'll keep trying to hit this until we're at a multiple of 10, so every 10 seconds it'll hit this statement. And then additionally, as I mentioned, we want to refresh our data at the top of every hour. So the way we're going to do that is if the minute is currently 0, and if the second is 10. So 10 seconds into the hour, at the top of the hour, we're going to refresh our data. Make a comment here for now, and just to kind of illustrate this a little better, we can pull up, I'm going to pull this to a different cell here. And if this is the case, we're just going to print hello. And then one other thing we'll want to do is wait for 1 second. We can use time.sleep for 1 second. This will just wait 1 second to make sure we don't hit this many times within that same second. So let's pull up, just have a digital clock here. We can just kind of watch how this works with respect to the actual time. So we can watch the clock and we can run this. As here, it's currently the 47th minute. Let's kick this off at 40 seconds. So we can run that. And as it hits 40, you can see we came into this if statement here just one time, and now this won't happen again until the top of the next hour. So when the minute is 47 again in this case, or in our actual case, when the minute is 0 and the second is 10. So this is still checking right now. We can stop that. Can delete this example. And as I mentioned, what do we want to do at the top of the hour? We just want to refresh our data. So in this case, we'll just call that gather data function that we've written previously. This will pass symbols and 48 hours. So then after we gather our data, the next thing we're going to want to do, run this for an example, just to have the data as an example here. The next thing we're going to want to do is get the current state of the market. We want to know, is the price of the cryptocurrencies we're interested in below the bands, is it within the bands, or is it above the bands? So the way we can do that is we're just going to iterate through each symbol. So for symbol in symbols, and we're going to create a dictionary here called states. So this will just allow us to track the state of each cryptocurrency. And we're going to check if the last close price for that symbol, so if that close price at the last index location, you can use -1 in pandas for this. So for Litecoin, for example, we're looking at this price right here, the last one of the data frame, because that's the most recent time we have. So if this is less than the lower band at the last index location. Then we want to track for our states. We want to add, or we want to set this to be below. If that's not the case, then we can create another check here, and we can check if this close price is above the upper band. If that's the case, we want to set this states symbol, or this dictionary states for that symbol to above. Otherwise, if it's not below the lower band and it's not above the upper band, then it must be between them. So then we can set this to inside. And so we can run that initially and just take a look at the states dictionary. You can see all of them are actually currently inside the bands. This is the most common scenario. Probably 95% of the time the prices are moved within these bands. Just to do a quick spot check on this, we can look at the last Litecoin price. It was 191.88, and the lower and upper bands are 189 and 195 respectively. So that is, inside those bands. So that appears to be working. And we're going to want to actually make this into a function, so we don't have to run this whole chunk of code every time we want to get the states. So let's just make a function called Getstates, and this will take in the data frame and the symbols. And then we want to tab that over, and we'll return that states dictionary. Okay, so now that we have that, I'm going to move this up with our other function here. Delete that. So now not only do we want to refresh the data at the top of every hour here, but we also want to refresh that states dictionary. So states equals get states df symbols. So now that we basically have all of the data we need to grab at the top of every hour, and now we can kind of focus on, so we have our thresholds. We have the thresholds at the upper band, the lower band, and we know what we're trying, or what would indicate a buy signal. What we still don't have is actually the price. We're going to have to watch the price throughout the entire hour, or we're going to check every 10 seconds actually. We're going to check, is that price below the lower band in the case of a buy, or above the upper band in the case of a sell. So the way we're going to do that is go to the documentation here, Binance API. There is a function called it's get order book ticker. Yeah, it's this one here. So to get an idea of what this does, basically you can just pass a symbol. We'll just check Bitcoin initially. Again, we got to specify the client every time we want to call the API. So you can see this returns the current symbol, or the symbol that you passed in, and then it gives you the bid price, bid quantity, ask price, and ask quantity. If you're not familiar with these terms, this is basically, if you look at an exchange here, this is these numbers here. These are the bids and asks on the exchange currently. So this is a more accurate way to know when you can buy, or what price you can buy and sell at. This is the actual bids and asks on the exchange. So if there's somebody on the exchange currently, the best bid on the exchange is at 61,766, and they are bidding for 0.3 Bitcoin. So if you have Bitcoin you want to sell right now, and you try to sell for 61,766, this person's order will fill, or somebody's order around this price will fill whatever amount of Bitcoin you're trying to sell. And so this is kind of the best way to know, even more accurate than the price itself, what price can you actually buy and sell at. We're actually just going to focus on the price for the purpose of this video. There's a scenario where you could actually use this quantity as well to know how much is available. For our purposes, we're never going to be buying a significant amount. Like 0.3 Bitcoin, for example, this is $20,000. We won't be bidding or buying or selling near that much, so it likely won't come into play. So every 10 seconds, we also want to know, are we looking for a buy or are we looking for a sell? So similar to how we did this when we were back testing, we're going to start with our balance unit as US dollars. And then we're going to check, are we currently holding US dollars? If so, we are looking to buy. If our balance unit is not US dollars, this means that we've already bought or we're currently holding Bitcoin, Litecoin, or Ethereum, and in this case we're looking to sell. So now inside this if statement, we're going to use this get order book ticker function to, in the buying case, we're going to need the ask price, right? This is what somebody's asking for. They're trying to sell their cryptocurrency. This is what they're asking. So to do that, we can just call that key item there ask price. And notice that this is actually a string, so we're going to convert this to a float. And there's our ask price. So the first thing we're going to do when we're looking to buy is log that ask price. The second thing we need to know to determine whether or not we're going to buy is what is that lower band. We can just simply grab that from our data frame. This will be symbol lower band at the last index location. So we have our ask price and our lower band. Lastly, we're going to check, is that ask price lower than our lower band? And this is our buy signal. And remember, we don't always want to buy if that's lower. We want to also make sure that the current state of, so the state's variable for that symbol, we want to make sure that's also inside, meaning it's crossing over the lower band currently. So state for that symbol is inside. So if we're currently inside the bands and the ask price crosses below the lower band, then we want to buy. And for now, I'm just going to print buy. We're actually going to cover this in kind of the ins and outs of actually executing that buy in the next video. Right now, we're just building the framework for making sure we have all the proper data and enough to calculate and determine when our buy signals are. And then obviously our balance unit needs to be whatever we just bought. I actually forgot to, we actually need to iterate through our symbols here, right? Because we want to check for all of our symbols or for each symbol in symbols. We're going to check, are we going to buy it? If so, if this is the case, we hit our buy signal, then we're going to execute the buy. We're going to switch our balance unit to that symbol, and we also want to break out of this for loop because we don't want to check for the other cryptocurrencies if we've already bought one. Theoretically, you could buy more than one. You just have to make sure that the balance in your account is enough to do so. We're actually just going to spend our whole balance on that one cryptocurrency just for simplicity reasons, but that is something you could theoretically do. You could check for all three, and you could theoretically buy all three if they all meet that buy signal. Okay, so that's our buy signal here. Next, we'll do the sell signal. This will be very similar. Basically, we want to know not the ask price, but the bid price. need to know not the lower band, but the upper band at the last index location. And we need to check if the bid price is greater than the upper band and the current state of our balance unit. So not the symbol, but the balance unit we're currently holding. If the current state is inside and it's crossing above the upper band, then this is our sell signal. And we'll just print sell for now. And then obviously our balance unit is no longer that symbol we were holding, but it is back to US dollars. This should actually be symbol here, or actually balance unit here. Yeah, so when we're looking to sell, we're going to be getting this data for the balance unit. When we're looking to buy, we're going to be checking all of the symbols within this for loop, and this should be symbol. Okay. So in summary, what we've done here is we're going to come into this if statement every 10 seconds. If we're looking to buy, we're going to check our buy signal. If we're looking to sell, we're going to check our sell signal. And then if it's the case that it's currently the first 10-second interval of the hour, we're going to refresh our data. So let's print a couple things here and run this just to see kind of where we're at. So after we hit our states, let's print current state of the market. And then we'll print states. Every time we'll just focus on the buy signal for now, because I don't imagine we'll be actually hitting this, just running it a short period of time here. So we'll print the ask price in the lower band. So let's do the symbol for ask price, and then you can do lower band. And then every time we check this, let's just print a new line, make our output nicer. \n is to just print a new line. And then the last thing we're going to want to do is we actually need to wait for 1 second at the end of this. And the reason for this is because Python's going to be much faster. It's going to be doing much more than one iteration per second. And so we don't want to hit these if statements twice in 1 second. We want to make sure these are uniquely for 1 second. So if we sleep 1 second, then it won't be able to hit that again. And run this. Oh, the last thing, forgot. So we didn't gather data. It was able to run because I had previously had data in df here, but it didn't actually hit this statement here. So on the first time, this is just so that you don't have to wait until the first second to gather your data. We'll just say if this is the first time it's coming through, we can add this little exception here. So or first. So if it's the top of the hour or the first time we're running, then we can set first back to false. Am I still gonna hit that? Oh, so we need to make sure this is inside this if statement here. And we actually want to do this on both if statements. Yeah, so we're just adding an exception. If it's the first time through, we want to grab our data and enter in, and then that will be turned off right away. So we have the current state of the market. All of our cryptocurrencies are currently inside the bands, and then every 10 seconds we'll get an update, and it'll say the best ask price is here, the lower band that is our target is here, and as soon as this number crosses below this number, we're going to hit our buy signal. And I'm not printing the information about the sells, but you could theoretically do the same thing there, and if you're looking to sell, you could print the same information for your sells. Or when you're actually running this live, you probably wouldn't be printing at all, just because that would be, end up being a very long output. But good way to visualize what's really happening here. There's a couple more things we need to do to make this, just to make sure this keeps running. There could be a variety of things that would halt this process if you hit an error for whatever reason. Maybe your internet connection goes out for a second, or whatever reason you can't make a connection to the Binance API. This will just error out and it'll stop. And we don't want this to actually stop. So one thing we'll do here, I'll stop this process. One thing we can do is if you go into the API and you look at exceptions, we can grab this chunk of code here. This is saying if you can't reach the Binance API on a call, this error will be raised. We are just going to try and accept that error. So I'll give an example of this here. This is in Python 2, so we'll switch that. And so this is going to error out on this statement here, just because we're not, this function requires a symbol, but we're not passing one. So it's going to error out, but you can see it actually will move on past this statement, and it'll still, so we still have this print being hit. And so this is Python's way of, instead of stopping on an error, you can list which error you're going to accept, and then just print the error instead. So you'll, in the case when you're running this bot live, you hit an error, it'll tell you hit an error, but it'll keep going. And you can think about the implications of this, or what this would mean. We're actually going to do this only on this second piece here. You could probably think of a way to do it on your refresh too, so that you try to refresh your data again. We're just going to, just for example purposes, show this on the second portion here, when you're looking to buy or looking to sell. So we're going to try this whole chunk. If we hit an error from the Binance API, it would be on this client order book ticker. We're just going to break out of this or move on, and we're going to accept the error. So if it is this Binance API exception, we're going to accept it and then just print the error like we have below. As I was saying, you can imagine the implications of this. You come in, you check your buy signal or your sell signal, you hit an error, and the only thing that would happen is you just didn't check the signal for that 10-second interval, which really wouldn't be that big of a deal. You just keep waiting, you keep printing out the errors until you make connection back to the API, and then it'll resume the process of checking the buy and sell signals. Yeah, so I think that will be all for this video. I'll kind of preface, I know we left these buy statements and sell statements blank for now. We're just printing, we're not actually placing buy and sell orders. But to kind of preface what we'll be looking at in the next video, the API has functions called order, one of them is order limit buy. There's also order market buy, order limit sell, order market sell. Those are the 4 functions we'll be using to actually execute our buy and sell orders on the API live. And there is a bit of nuance that goes into this. It's not as easy as in the backtest. There's always going to be some little discrepancy between trading live and the backtest, and our goal will be to get as close to that backtest as possible. So the whole process is you backtest a strategy that you're comfortable with, and then when you implement this live, you want to make sure that your strategy is being executed as close to what is happening in the backtest as possible. And the way to do that is there's all kinds of things that can go wrong, like slippage we'll talk about. So there's just kind of some nuance that goes into this, which is why I'm going to save it for the next video. And we'll actually go into the details of executing those buy and sell orders. I think after this video you should have the tools, and if you kind of read up on those functions in the docs, you should be able to experiment with this and see if you can get those functions to actually execute orders for you. But yeah, that'll be all for this video, and I'll see you guys in the next one.